This is the 4.4 and 4.7 review, and we are on to the calculator section. So that means I'm going to be using the calculator to do a lot of this stuff. We will do the setups and the domains by hand, and then we will use the calculator to answer everything else. So if we look at number 7a, it says I've got a rectangle with a base on the x-axis that's inscribed under the graph of this parabola. So I will sketch my parabola that opens down, and I will put in a rectangle, and we want to find the dimensions of the rectangle with the largest area. So when I'm done, I need to have the dimensions. I need the base and I need the height. So that's what I'm heading for at the end. In order to get there, I want the largest area for that rectangle. So that means my job is to write the area of this function in terms of a single variable x. So just like we did in class multiple times when we did problems of this nature, we let x represent the distance from the origin to the right edge of whatever shape we're working on. When we do that, we can generate a point that has both horizontal and vertical information. The x-coordinate will be the x, the y-coordinate will be the output of the function, which is 8 minus 2x squared. So now when I write the area of the rectangle, I need the base, which is 2 of those x's, times the height, which is the y-coordinate, 8 minus 2x squared. So I am now going to move to my calculator, and I'll put that area in. Let me clear out everything. I'm going to go to my Y editor and clear these things out. And in y1, I'm going to put that area function, which was 2x times the 8 minus 2x squared. And then I'm going to think about the domain and the fact that I need a derivative. So the derivative of this I'll put into y2, so I'll do second 8, which accesses the derivative command, and then I'll take the derivative of y1 of x with respect to x. So hopefully you can see that in there, the derivative. I hit enter. Now I've got the derivative in y2 and the original function in y1. Our goal is to get the largest rectangle, so that means we would need y2, or the derivative, to cross the x-axis from above to below. So there are two ways that we can do this. We can either graph our derivative and wait for that derivative to come out on our picture, or we can go to the home screen and solve for when that derivative is 0, and then just verify using a sign chart that that's indeed what happens, that we get the change from positive to negative. So I'm going to turn off y1, and I'm going to think about the domain. If we go back to our picture here, remember that the domain comes from the values of x that will make this get 0 for a base or 0 for a height. So we can see that x can get as small as 0, and we can see that y, if that becomes a 0, this y-coordinate, that x is actually going to be 2. So we're looking in the domain from 0 to 2, and we're going to do it on the home screen because I think that's a little faster than waiting for the graph. So I'm going to go to my home screen, and I'm going to solve, which is F2, for when my derivative, which is stored in y2, I want to know when that equals 0. When I do this, I will get two different answers, and notice one of them is negative, that's not in the domain, and the other one is positive, so that one is in the domain. So I can check using a sign chart to see whether I'm positive to the right or to the left and negative to the right, or I can just plug in some values. If we look at this, I've got a 2/3 times something, so chances are 2/3 would be smaller than that, so I could just do y2 of 2/3. And I can see that that is a positive number, and a number that's bigger than that might be, say, 1.9 if I get really close to 2, so I can put in a 1.9, and I have a negative number, so I can see that my derivative, which was y2, changed from a positive to a negative around that value. So because of that, I know that this is the location of a maximum. The question was, when do we have a maximum, and what are the dimensions of that rectangle? So we have figured out that x equals 2 root 3 over 3 is the location of the max. So out of that, I need to get the dimensions. So the dimensions of the rectangle were the base, which was 2 of those x's. So if I multiply this 2 root 3 over 3 times 2, I'm going to get it one dimension that is a 4 root 3 over 3. And then the other dimension comes from this y coordinate with that number plugged in. So I can do a 8, I'm having a hard time seeing this. I can do an 8 minus a 2 times that value, a 2 root 3 divided by 3, and then I'm going to square that. Hit enter, I get a height now that is 16/3. Finally, the last thing that we see is the question, what is the area? So the area will be that 2 root 3 over 3 plugged into the area function, which we stored in y1. So we can do y1 of that 2 root 3 divided by 3. And we see that the area is 64 root 3 over 9. And we're done.